We've got here is a graph question, and actually a describe the graph question. Here it's asking you to describe a relationship between wibble and wobble. What are wibble and wobble? It doesn't matter. These are two just things. I've invented the graph. With these describe graph questions, you don't need to know the physics at all, but they're really common questions in a physics paper. They're very often 2 marks, and you don't need to know the science behind them at all. All you need to know is, how am I going to describe this graph? How am I going to describe this relationship between these two things that this graph shows? So here we've got these two things called wibble and wobble. We've got a graph that shows how they relate. The 2 marks, 1 mark is always to describe the general trend, and then the second mark is to show that you recognize that there is a trend here, but there's a little bit more going on, describing if there's a curve or if that trend is changing. Okay, so here we can say we're changing wobble and we're looking at how it affects wibble. How do we know we're changing wobble? Probably we're changing wobble because it's the independent bottom horizontal part of the graph. Okay, so how are we going to describe this? We can start by just describing the initial straight line nature of the start. We can say that the relationship between wibble and wobble to start off is linear. Or we could say that it's directly proportional because there's a straight line going through the origin. Or if you wanted to, you can just say, as wobble increases, wibble also increases. And that would be enough to get you 1 mark. The second mark is going to be in relation to the fact that the top of this graph is curved. That bit there is going to get you the second mark. And so you've got to be comfortable saying, right, how can I describe this? And where the graph flattens out like that, what's happening is wobble is still increasing, but wibble isn't increasing as much. So that's what you'd say. You would say later on, when we get to larger values of wobble, then the rate at which wibble is increasing starts to lessen, or the graph starts to flatten out. So that shows that wibble doesn't increase as much as it was at the start. You do want to do that comparison. If you're saying how wibble is changing is not the same as at the start, then you do want to say, so this is what it was doing at the start, this is how it's different from that. So you could say there's a linear relationship at the start where as we double wobble, we also double wibble. That's your directly proportional relationship. Or there's a linear relationship. But then the second bit, when we get to higher values of wobble, now how quickly wibble is increasing is not as big as it was at the start. The graph, you can't just say the graph levels out because you've then got to relate it to what that means in terms of the relationship of the two. So you can say the graph levels out, but then you'd have to say, and that means for larger values of wobble, now wibble isn't increasing as much as it was at the start.